Greetings of the day. I am Dr. K. Raghu Mohan Reddy. The course name is Unconventional Machining Process. Topic is Abrasive Water Jet Machining and Material Removal Process. The course name is Unconventional Machining Process. Topic is Abrasive Water Jet Machining and Material Removal Mechanism. So these are the course outcomes. At the end of this session, student will be able to understand the working of abrasive water jet machining process, understand the material removal rate mechanism of abrasive water jet machining and its parameters, explain the applications of abrasive jet machining process, explain the advantages and limitations of abrasive jet machining, and also student can be able to compare abrasive jet machining and abrasive water jet machining. So in simple, AJM refers to abrasive jet machining and AWJM is abrasive water jet machining. Okay. This is abrasive water jet machining. This is simply abrasive jet machining. Okay. So in the subsequent slides, AJM refers to abrasive jet machining. AWJM refers to abrasive water jet machining. Right. However, let us go through the basic non-traditional machining process chart. So here under this we have three broad categories like mechanical, thermal, chemical and electrochemical. So far we have seen under mechanical ultrasonic machining that we have completed, and in the last video we have discussed abrasive jet machining. Okay, now we are going to cover water jet machining and abrasive water jet machining and its comparison. Right. What is water jet machining? Okay. Water jet machining is suitable for cutting plastics, food, rubber, automotive, carpenting and headliners and most textiles. So all these are very soft materials. Okay. So by using water jet machining, we can cut plastics, food, rubber insulation, automotive carpeting and headliners and most textiles. Okay, right. What about hard materials then? Harder materials such as glass, ceramics, concrete and tough composites can be cut by adding abrasives to the water jet during abrasive water jet machining. Okay, if we include abrasives to the water jet machining, then that is said to be abrasive water jet machining. Okay, which was first developed in 1974 to clean metal prior to surface treatment of the metal. Okay, usually when we hit with sharp-edged abrasive tools over a surface of any plate, then it can be cleaned if it has some dirt or some unwanted particles deposited on the surface because of the climate conditions. Okay, right. Now, the addition of abrasives to the water jet enhanced the material removal rate and produced cutting speeds between 51 to 460 millimeters per minute. Okay, right. So here Without abrasives, we cannot expect material removal rate in more quantities. Of course, addition of abrasives will definitely improve the material removal rate. Okay, and at the same time, cutting speeds also between 51 to 460 mm per minute. Why? Because of the high velocity of these abrasive particles, the overall velocity of the cutting will be improved. Okay, right. Generally, water jet abrasive water jet machining cuts 10 times faster than the conventional machining methods of composite materials. So this is the specialty of abrasive water jet machining. Okay, so because of this conventional machining methods, we will get some x times speed. Then with this abrasive water jet machining, that it will be 10x times. Process parameters. Abrasive water jet machining uses a low pressure of 4.2 bar to accelerate a large volume of water, that is 70% of water and 30% of abrasive. Okay, so the mixture or the composition of abrasive slurry is that 70% of water and 30% of abrasive. Okay, water less abrasive. This is nothing but abrasive slurry or the medium. Okay, so up to a velocity of 30 meters per second. Right, these are the process parameters of abrasive slurry. Next, the mechanism and the grain size and the other things of abrasive water jet machining elements is shown in this figure. Right, here already we have discussed that abrasive slurry contains 70% of water and 30% of abrasives. Right, here silicon carbides, corundum and glass beads of grain size 10 to 150 microns are often used as abrasive materials. Okay, so here the abrasive materials are silicon carbide, basically we use. Okay, corundum, that is aluminum oxide. Okay, and the grain size is 10 to 150 microns. Okay, of random shape and size. Okay, all the particles may not be equal in grain size. Randomly, it will vary from 10 to 150 microns. Control value and variable mixture, that it will go to nozzle end. So with high kinetic energy, the abrasive slurry will strike the workpiece as a jet so that the material removal will take place. Okay, so this is the mechanism behind this abrasive materials, the abrasive water jet machining. Right, the machining system of abrasive water jet machining. Right, in abrasive water jet machining, the water jet stream accelerate abrasive particles. Okay, so that is nothing but kinetic energy of the abrasive particles. Right, not the water to cause the material removal. That means Here water will help to increase the acceleration of the particles. Okay, it will not directly use it to cut the material, or it will not strike the material to cause the erosion. Okay, the abrasives will play predominant role in material removal. Right. After the pure water jet is created, abrasives are added using either the injection or suspension methods as shown in this figure. So here one is injection type. Okay, the other one is suspension type. Let us see the various parts here. The water is allowing from top. Okay, so here the pressure generation mechanism will be adopted here. So the pressure of the water will also increase. Okay, so here the abrasive reservoir. Okay, so this is machining head. Here water nozzle will be arranged to accelerate the water. Okay, so here the focusing tube, so that the mixture of water and abrasive particles will come as a jet, and with side feed mechanism or phenomena, it removes the material of the workpiece surface. Right. Here in this, again water. Here also the pressure generation mechanism will be adopted, and consecutively the pressure of water will improve. This is abrasive storage connected to this direct channel of this water again. Again it will pass through the main tube. Okay, so here a suspension is provided. The slurry will pass through this suspension, and this suspension nozzle accelerates the abrasive slurry, and with this central feed phenomena, it cuts the workpiece surface. So these two are the two mechanisms, right? Next, parameters of the abrasives. The important parameters of the abrasives are material structure and hardness, mechanical behavior, grain shape, grain size, and its distribution. Okay, first one is material structure and hardness. Next, mechanical behavior, grain shape, grain size, and grain distribution. These are very much important in material removal rate of this abrasive material. The basic machining system of abrasive water jet machining. So however, in the previous figure we have shown the skeleton mechanism, okay, here, but the basic mechanism of this abrasive water jet machining comprises all this: water delivery system that we have seen, abrasive hopper and feeder that we have seen, intensifier. Intensifier means it increases the velocity. Next, filters. See, always abrasive slurry may have different grain size. The filter filters certain bigger size grain size particles. Okay. Next, mixing chamber, cutting nozzles, and catcher. Right. Next, process capabilities. Typical process variables include pressure, that means pressure of water, nozzle diameter. Okay, so nozzle diameter is also play an important role. Okay. Right. Standoff distance, that is nothing but distance between the tip of the nozzle to the workpiece surface. Okay, this is nothing but standoff distance. Next, abrasive type, grit number and workpiece feed rate. Okay, so these are the process capabilities of this abrasive water jet machining. Right. An abrasive water jet cuts through 356.6 mm thick slabs of concrete or 76.6 millimeters thick two steel plates at 38 mm per minute in a single pass. So you can imagine how best it cuts the concrete and two steel plates. This much thick, 356.6 thick. Okay, and speed is 38 millimeters per minute. In 1 minute, it cuts 38 millimeters in a single minute. Okay, and the plate thickness is how much? 356.6 millimeters thick. Okay, of concrete. For tool steel, 76.6 mm. Okay, right. The produced surface roughness ranges between 3.8 and 6.4 microns. Okay, regarding surface roughness, the value is 3.8 to 6.4 microns. And the tolerance is plus or minus 0.13 millimeters. Okay, right. Next, repeatability of plus or minus 0.04 mm, squareness of 0.043 mm per meter, and straightness of 0.05 mm per axis are expected. So these are the some numerical data or information about this abrasive water jet machining. Right. Some additional information of this abrasive water jet machining about glass cutting of brittle material category. During the machining of glass, a cutting rate of 16.4 cubic millimeters per minute is achieved. Okay, for glass materials, it is 16.4 cubic millimeters per minute, which is 4 to 6 times that for metals. Okay, so though the glass material is very much brittle, this abrasive water jet machining is best suited because it is as faster as to that of other metals. Okay, it is 4 to 6 times that of metals. Right. Surface roughness. Surface roughness depends on the workpiece material, grit size, and type of abrasive, whether it is coarse type or fine. A material with a high removal rate, okay, high removal rate produces large surface roughness. Okay, so if we want high removal rates, it will be obviously lead to large surface roughness. Right. Regarding fine grains, fine grains are used for machining soft metals to obtain the same surface roughness as hard ones. Okay, so here for soft metals, see here, we have to go with fine grains. Okay, in order to maintain same surface roughness. Okay, right. The decrease of surface roughness at a smaller grain size is related to the reduced depth of cut and undeformed chip cross section. This is very much important. Okay, again, once again, the decrease of surface roughness at a smaller grain size is related to the reduced depth of cut and undeformed chip cross section. Okay, depth of cut be reduced. Right. A carrier liquid consisting of water and anti-corrosive additives has a much greater density than air. This is very obvious, no doubt. This contributes to higher acceleration to the grains with a consequent higher grain speed and increased metal removal rate. Right. Applications: drilling holes, cutting slots, cleaning hard surfaces, deburring, polishing, and radiusing are the first set of applications by using abrasive jet machine. Second one, deburring of cross holes, slots, and threads in small precision parts that require a burr-free finish, such as hydraulic valves, aircraft fuel systems, and medical appliances. Next, third one, machining intricate shapes or holes in sensitive, brittle, thin, or difficult to machine materials. Okay, machining intricate shapes or holes in sensitive, brittle, thin, or difficult to machine materials. Usually, when we make holes or machining intricate shapes, it is subjected to different forces and it will subject to what is it called, stress concentration factor. So because of that, the brittle materials will tend to propagate a crack, okay, in different material removal process. But here, with this process, we cannot find any cracks, initiation or propagation. Okay, that is the chief advantage of this abrasive water jet machining. Okay, fourth one, insulation, stripping and wire cleaning without affecting the conductor. Next, micro deburring of hypodermic needles. Okay, micro deburring of hypodermic needles. This is very much important. Sixth one, frosting glass trimming of circuit boards, hybrid circuit resistors, capacitors, silicon and gallium. Next, last one, removal of films and delicate cleaning of irregular surfaces because the abrasive stream is able to follow contours. Okay, so just once again I read out: drilling holes, deburring of cross holes or slots. Third one, machining intricate shapes. Fourth one, insulating, stripping and wire cleaning. Fifth one, micro deburring of hypodermic needles. Sixth one, frost or frosting glass and trimming of circuit boards. Seventh one, removal of films and delicate cleaning of irregular surface because the abrasive stream is able to follow contours. Okay, so different contours will lead to some problem in other machining process, but whereas in this abrasive jet machining process, this will follow abrasive stream is able to follow contours. Okay, right. Next, advantages and limitations of abrasive jet machining. Advantages: because abrasive jet machining is a cool machining process, it is best suited for machining brittle and heat sensitive materials like glass, quartz, sapphire and ceramics. Usually we feel difficulty while we are machining brittle materials. Why? Because all of a sudden the brittle material will lead to fracture without any notice. So here abrasive jet machining process is best suited for brittle materials and heat sensitive materials like glass, quartz, sapphire and ceramics. The process is used for machining superalloys and refractory materials. Nothing but hard materials. Usually it is very difficult to machine or cut hard materials with other machining process, but in non-traditional machining process, the abrasive jet machining process is best suited for superalloys or refractory materials. Next, it is not reactive with any workpiece material. So here the abrasive materials will not react with workpiece material. So there will not be any harm. Right. No tool changes are required. Here there is no question of tool. Okay. So the abrasive slurry will come out high kinetic energy through the nozzle. So here the nozzle and the abrasive slurry are the two important elements. The nozzle directs the abrasive slurry which strikes the workpiece material so that the workpiece removal or the material removal will take place. Right. Intricate parts of sharp corners can be machined. Okay. Since the abrasive medium follow the contours, so we can make intricate shapes on the parts which are having sharp corners. The machined materials do not experience hardening. Next, no initial hole is required for starting the operation as required by IARE. Okay, so some pre-process is required for this electrode discharge machining. Okay, IARE is why electrode discharge machining process requires some pre-process like make initial holing. Okay, here it is not required. Material utilization is high because the abrasive slurry passes or strikes the workpiece material to remove the material, and after removal of the material, the abrasive slurry again will be collected so some tanks and it will be filtered again, it can be reused. Okay, right. It can machine thin materials too. Okay, so usually brittle and thin materials are very difficult to machine, but using this abrasive water jet machining process, right. Limitations: the removal rate is slow, stray cutting can't be avoided. Okay, that is low accuracy of plus or minus 0.1 mm. The tapping effect may occur especially when drilling in metals. The abrasive may get impeded in the work surface. Suitable dust collecting system should be provided. Soft materials can't be machined by this process. Okay, this is one of the biggest limitation. But however, machining brittle materials is somewhat difficult, but it can be possible with this machining system. Silica dust may be a health hazard. Usually, silica dust damage the nervous system and skin of the human beings. Ordinary shop air should be filtered to remove moisture and oil. So this is another limitation of this system. So as a whole, we need to compare abrasive jet machining and water jet machining. So in summarizing, in abrasive jet machining, the abrasive particles used are typically harder materials such as aluminum oxide, silicon carbide or garnet. These hard abrasive particles are mixed with a gas, usually air or nitrogen, and accelerated to high velocities to perform material removal through erosion. Third one is abrasive jet machining is suitable for machining hard and brittle materials like ceramics, glass and certain metals. Water abrasive jet machining. Water abrasive jet machining, on the other hand, uses water as the primary carrier medium instead of gas, along with abrasive particles. The abrasive particles are mixed with water and propelled at high velocities towards the workpiece surface. The water in water abrasive jet machining acts as a carrier for the abrasive particles and helps in controlling dust and debris. Water abrasive jet machining is typically used for softer materials such as plastics, rubber and even some metals. Additionally, water abrasive jet machining is often preferred for applications where heat generation is a concern. Water helps dissipate heat more effectively compared to gas, right? So here it is clear that in water abrasive jet machining, the water is the primary carrier medium. Okay, in abrasive jet machining, the carrier medium would be gas. That is the only difference between abrasive jet machining and water abrasive jet machining process. Okay, right. In summary, the main difference between abrasive jet machining and water abrasive jet machining lies in carrier medium used. Usually, gas in abrasive jet machining, water in water abrasive jet machining. That's what we have discussed. Both utilize abrasive particles to aerate material from workpiece surface. So in both the cases, we are using abrasive particles. Okay, each method has its own significance, and based on the applications, we have to make use of this. These are the references. Okay, so with this, I conclude this topic. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.